Welcome to Bits and Bots. In this video, we will discuss the basics along with the function example of Matlab. Matlab is a powerful tool in which you can analyze real-world problems and simulate them. It allows a programmer to use different algorithms and control different hardware. Let's start with some basics. In the default layout, you can see it in the top left corner. There are three buttons: Home, Plots, and Apps. The Home button consists of different functions from which we can create new files. It can also be used to import the data and save the data. In the Variable panel, we can add new variable and open the variables. And we can also clear the workspace. The Variable panel is also used to import the data and save the workspace. The Code panel contains different buttons through which you can compile the code. It can also be used to clear the commands and analyze the code. The Simulink button allows you to open the Simulink window. Similarly, next to the Simulink button, you can see there is a Layout button. It is used to change the Matlab window. The Preferences button allows you to change the configuration of the Matlab. The Add-on button allows you to download and install different packages. The Help button is used to access the help database of Matlab. Now let's move towards the function of each button. When we click on the Script button, it opens a new window, where you can type your code and save .m file externally. Let's move towards the next button, the New Live Script button. It also opens the script view, which allows you to enter the script command lines in the Matlab window. However, the difference between these two buttons is that of view. Its view allows you to type the commands and executes only when you will press the button. The Live Script button allows the compiler to reduce these instructions in order to read the command instructions and compile. And, if there is an error that occurred in the code, then it will show it during the execution of the code. Let's move towards the Another button, which is called the New button. Through the New button, you can add script, live functions, class, and multiple functions, which we can open in the New button. Next to the New button is the Open button. It allows you to open the files externally through the data which you have saved earlier. Next to it is the Import button. It allows you to import the variables data to be used in the Matlab environment. Next to it is the Save Workspace button. It allows you to save the variables and allows you to save the workspace data in an external file, to be used in another program. When we press the Simulink button, it will open this environment. Simulink is a very powerful tool of Matlab. It has different functions which will be discussed in the coming videos, separately. Let's move towards the basic features of Matlab. In the basic features of Matlab, there are main three features which we can perform in the environment. It allows the programmer to program in Matlab. And the script view, which you can see. And the Simulink view, here you can see it. And the App Designer view. In the App Designer view, when you press the Design button, it will open another window, through which you can design in different apps, the desktop apps. Further, we will discuss the functions in a separate video. However, our main focus in this video is to learn the basics of Matlab. The Current Folder window allows you to see the current location of the folder in which Matlab is saving its programs and executing the program from a specific location. The workspace allows you to see the variables which we have used in the program. Also, the user can view the data stored in these variables. Now, let's move to the command window. In the command window, Matlab allows the programmer to type the program. It compiles these command lines and shows the output. If any of the conditions violate, it displays the message. Let's have a look at this address bar. It shows the address bar of a specific directory, in which accessed in the current folder of the directory. Now, let's move towards the coding of Matlab. In the command line window, we will demonstrate some code lines with you and show you how Matlab responds to these code lines. First, declaring a variable. We will start with clearing the workspace data and database of Matlab if there is any program we have compiled on it. We will start with the command of clear all. Now we can see in the workspace that name of the variable is x, and its value is 8. The system is busy right now. When the system is busy, you can see these arrows don't appear on the screen. As soon as the system is ready, then these arrows will appear and will allow the user to input the data. Now, you can see the workspace window is blank, and the arrows appear. Now in the command line window, we will enter commands into the Matlab. Let's use Matlab as a calculator. Let's say, we define a variable called x, with a value of 1. When we press enter, we can see in the workspace window that there is a value of 1, and variable x. Let's say, we define another variable, with a value of 4. When we press to enter, the workspace will also store in its database, with the value of 4, and the name of the variable, called y. Let's say, z is the initial of these two variables. We shall make it x plus y. On pressing the enter, you can see, the workspace also stores this data of addition of x plus y, with the value of 5. So, it means that the user can use Matlab as a calculator. Let's perform other mathematical functions in our command line window. X minus y. As it is script language, it is sensitive to letter cases. Let's say, if we press capital Y, it will display an error message of an undefined variable. And it is not in the directory, it just asked me, did you mean, why yes? I said, let's press enter. And it is, y. It will display the message at, y. As you can see, as I wrote, x, minus, y, and I don't use any other variable to store the subtraction results in a variable. The Matlab use the answer variable by default, and store the answer in it. Let's say we again do the same function without signing a variable called x divided by 2. By this, we get 0.5. As you can see, it uses the answer variable by default in the workspace with its updated value. Let's say we will perform the multiplication. X multiplied by y. As you can see, the value of the answer variable has been updated. Now we will do the same function in the scriptive window. When I press the script button, it opens the editor window, in which we can type our programs and execute the statements. The output appears in the command line view. First, we have to save it. When we press the Save button, it saves the file by the name of, as you can see, it is untitled file, in the practice folder. The address of the folder we have saved it in the D folder of practice. It will appear there. After pressing the Save button, it will appear in the current folder window, with the name and the title of the file. Here it is called, untitled5.m. Now, we will design a calculator, in the script view. Let's say we have a variable called, x, equal to, input. Or let's say, x equal, to, 2. Y is equal to 2. Z is equal to x plus y. When I press the Enter button, it will move the cursor to the next line. However, in the command line view, when I press the Enter, it will execute the code line and shows the output. Command line number 3 performs the addition. Let's say another variable called subtract. It is equal to x minus y. As you can see, we don't have placed any colon marks at the end of each command line. Multiplication is equal to x multiplied by y. Similarly, the division is equal to x divided by y. As you can see, as I don't place the colon button, the equal sign appears to be highlighted. As I move the cursor on it, it will display the error message that y it appears. You can also compile this error by using the built-in function of the Matlab. As you can see, as soon as I press the fix button, it has placed the colon. First, let me show you the function of the colon in this program. Let's clear the command window by writing clc and clear all. By writing the clear all command, it will clear the data which we have used so far. Let's run this file. As you can see, the variables are saved in the workspace environment and you can see the output at the command window. As you can see, the y variable appears to be in the command line window. However, the x variable cannot be seen in the command line due to this colon sign, because while I press the colon button, the compiler considers it as a terminator. It compiles and stores it but not display its data on the command line window. Let's update our code. I will place colon at the end of each line. You can see the highlighted mark is disappearing. Now to view our results, we will use the display command as addition of x plus y. Or let us say x plus y. We will place the colon sign at the end of display command, but the display command is executed and displays the result in the command line view. As the display command is designed to display the data, if we place the terminator sign at the end of this line, it will terminate the function, but it will perform the specific function for which it will design. So now we will display the result as display Z and place the colon. Now we will run the code. There is a small mistake in line 7, let's correct it. Now after executing the code, you can see in the command window x plus y is equal to 4. Similarly, we will use these command line to display other functions. We will display the data for addition, subtraction, multiplication, and division. As you can see in the code, the compiler will show the result on the screen. Now let's run the code. As you can see, the output that appears on the command window: x plus y is equal to 4. X minus 5 is equal to 0. X multiplied by y is equal to 4. X divided by y is equal to 1. We can also make the program to take the input from the user. Here, we will use the command as input. The text we want to display will be written in brackets. Input value. Now when the compiler will compile this code on the command window and show the input value, it will take the input data and store it in the x variable. We will use the similar command lines for other variables. Now, the user can use his own data to perform the calculator functions. Let's clear the previous data by writing clear all. Now we shall press enter. You can see, when the compiler compiles the code, it asks the user for the input value. Let's type 16. For y, let give input value 1. You can see the output appears on the screen. 17, 15, 16, 16. The corresponding functions, addition, subtraction, multiplication, and division. The Matlab compiler compiles the code and displays the data and output on the screen. It allows the user to input data, and shows the output on the screen. Let's define a new variable, selection. Input, select the operation. In the next line, write, if, selection equals. Add. And then, z equals, x, plus, y. And display the data on the screen. Further, if, else, statement in Matlab can be written as shown on the screen. When we place the arrow mark on the if statement, it shows the marks that we did not use, end statement. So, it is good practice to follow the syntax. Now let's write code line for subtraction. We shall do the same for other functions. Now let's save and run the code. Let's say, input value, 5, another value, 6. Select the operation. Let's write add. Here is an error. It has the integer data type. Let's update the code. Let's assign an integer to each function. Now let's again run the code. Input value, 5. Input value, 1. Select the operation, 1 for addition. The input command only uses the integer data types. Let's clear all memory first and also clear the command window by executing the following command, that is clear all. Clean up the whole memory of Matlab including the workspace window. CLC, clean up the command window only. As we execute the code, the compiler is the user to input the value first for variable x and then for y. Creating a variable topic has been covered. Just as variable x equal to 8. It is stored in the workspace. Similarly, overriding the variable. We can overwrite the variable suppose x is equal to 7. As you can see, when we press enter, the value has been stored in the variable x. The compiler has updated the workspace. Now for the error messages. Let's say, y is equal to f. The Matlab shows an error on the screen. We cannot assign a variable to a variable. We can assign a string to a variable. Let's say, y is equal to f. Now it has stored the string into the variable. Now we will see how we can plot our data into the Matlab. Now for the plotting statement, and we'll learn how we can make a plot in Matlab. To learn the basics of plotting, we will first learn how we can declare arrays. Let's say we have two arrays with a name x and y. Assigning values to array x and y, it must be considered that the equal number of values must be present on both arrays if you want to perform any mathematical or plotting operation. Let's perform a mathematical operation on array x and y and save the data in T. The error message shows that array T is mismatched with the array size of x and y. It instructs us to perform element-wise multiplication operation by replacing multiplication sign with dot multiplication. Now we can see the result after performing the multiplication operation with the dot multiplication operator. It performs an element-wise multiplication operation on the element on both arrays, that is, x and y. Now we will move toward the plot statement and draw the same basic plots. Plots can be drawn in Matlab by considering the plot statement. The first element in the plot x, y statement represents x-axis data while the second element represents y-axis data. After executing the code, we can see that data of X arrays appears on the X-axis while data of the Y array appears on the Y-axis. We can also make the plot by just considering a single variable, i.e. plot, Y. The first element in the plot x, y statement represents X-axis data while the second element represents Y-axis data. After executing the code, we can see that data of X arrays appears on the X-axis while data of the Y array appears on the Y-axis. We can also make the plot by just considering a single variable, i.e. plot, Y. The first element in the plot x, y statement represents X-axis data while the second element represents Y-axis data. After executing the code, we can see that data of X arrays appears on the X-axis while data of the Y array appears on the Y-axis. We can also make the plot by just considering a single variable, i.e. plot, Y. However, the X-axis is set by default values from 1 to 5. The compiler just considers the number of elements stored in the Y array and assigns the X-axis with a value from 1 to 5. Let's move toward a subplot and compare the two different plots on the same window. Subplot x1, x2, x3 statement along with the plot statement is used for this purpose. Let's use this statement and see what happens. The error shows on the screen shows that we missed the commas in the braces. Let's debug this error. After following the full syntax of the subplot statement, we remove the error. Let me explain the syntax of the subplot x1, x2, x3 statement. The first element tells the compiler how many plots we want to draw in a single window. The next two elements x1, x2, tell the compiler about the first position of graph 1 on the same window. Subplot 2,1,1 makes the compiler draw two graphs on a single window and 1,1 that the position of the graph on the same window should be at the first column and row. Then the plot statement is used to draw the plot of specific data. Now we have drawn two plots on the same window. We can compare the x-axis and y-axis data of both graphs. It can be seen that the y-axis of both graphs is different from each other according to the data stored in the x and y array. So far we have learned the basics of Matlab programming, including an introduction to Matlab, basic features of Matlab, creating Matlab variable, overwriting variable. Using Matlab as calculator, error message, error debugging, basic plotting, creating simple plots. We hope that you find this video useful. Kindly like and share the video if you learn the basic concepts. Moreover, kindly subscribe to our channel to remain updated to our latest videos.